In this video, I'm going to quickly go over the Pearson correlation. Just give you an overview to see what it's about. And then I'm going to give you a video on how to calculate the Pearson correlation coefficient, which is a number. You give a number to the Pearson correlation. And then I'm going to go back and kind of go in more depth about certain things about the Pearson correlation. But first, I just want to give you an overview. So if you don't get everything the first time around, that's okay, but I just want you to get kind of a sense of what the Pearson correlation is before you calculate the number for it, okay? And we're doing a bivariate analysis with two variables, and those variables have to be scale variables. So this is only for those numeric variables, okay? So don't do it between categories like gender and ethnicity. That you can't do a Pearson correlation on, okay? So the Pearson correlation tells you the direction and strength. So it gives you two things. And again, it's only on two scale variables, and it tells you how they move together and how much, okay? And it's only for linear relationships, so that means straight relationships, not curved. And that means the relationships will stay at the same direction and move at the same rate. So the first thing we're going to talk about is direction. So remember, the Pearson correlation tells you direction and strength. Those are the two things, direction, strength. So direction tells you, do the variables tend to move in the same direction or the opposite direction of each other? We can have a positive direction and we can have a negative direction. A positive direction is when the variables move in the same direction. So for example, if you have stress and depression, typically as someone's stress increases, their depression also tends to increase as well. So this isn't talking about a single person per se, but overall trends of a bunch of people. So it's not saying that this is always going to happen, but it's going to tend to happen. It's a pattern of results. And then for a negative direction, it's saying that if one variable increases, the other one will tend to decrease. So say we have stress. So as stress increases, your happiness probably will tend to decrease. So that's the pattern of results. As stress increases, your happiness tends to decrease. So they're moving in the opposite direction of each other, and that would be a negative direction. Then here we have strength. So strength tells us how consistently the variables move together, or how well you can predict y, our outcome variable, with our x, which is our predictor variable. Or you can say that our independent and dependent variable. But it does not tell you the rate of change, how fast one variable moves in comparison to the other one. So we'll go in a bit more detail about that. But strength tells you how well you can predict our outcome variable with our predictor variable. So if you can predict it with 100% accuracy, that's perfect strength. So if I tell you what your predictor variable is and you can tell me exactly what the outcome variable will be, that is perfect strength. If it's really fuzzy and you can't tell with very much accuracy, then that's a low strength. Here we have the Pearson correlation coefficient numbers that it can go from. So when you calculate it in the next video, you can go from -1 to +1. So it can be 0. 0 means there's no correlation. -1 is a perfect correlation, and so is +1. It is also a perfect correlation. And then you have variations in between. So the further away you are from 0, the stronger the relationship is. And the closer you are to -1 or +1, the stronger the relationship is. So don't confuse strength and the sign. So the direction and the strength are not really they're not the same thing. So a +1 and a -1 have the same strength, but different directions. So the -1 has a negative direction, and the +1 has a positive direction, but they both have perfect strength. So just keep that in mind, not to mix those up. Okay? So it's more about the number, not the sign, when we talk about the strength. I'm just going to go over how to create a scatter plot, just in case you don't know how. So here we have our scatter plot. The independent variable or the predictor variable will be on the x-axis, so that'll be stress, and the dependent or the outcome variable will be on the y-axis, and in this case it will be happiness. So that's just how we typically do it, okay? And so say we have person 1 and they have a stress level of 1 and a happiness level of 22. So we're going to put a line at 1 here for their stress and a line at their happiness level. And that's at 22. And where they intersect is where we're going to put a dot. So that dot represents person 1. Okay? And at their intersection of their two variables of stress and happiness. Then we do that for the next person. So we had a stress level of 2 and a happiness level of 12, and that's where the intersection is. And then we do that for the third person and the fourth person. And now we have a complete scatter plot with an N of 4. Here we have data with a positive direction. So you can see as the stress level increases, so if we go down, this tends to increase from 10 to 23 to 35 to 42. The depression levels also tend to decrease. So they're going together. So it's going from 3 to 6 to 10. So as stress increases, depression also tends to increase. So we have a positive direction. So we could have, for example, R of 0.98. So this is very strong. It's positive and it's very strong because it's close to 1. So that's just an example of what the Pearson correlation coefficient will be. And the R represents the sample Pearson correlation coefficient. So that's the symbol we're going to use for the Pearson correlation coefficient. Here we have a negative direction. So as stress tends to increase, our happiness tends to decrease. They go from 10 to 23 to 35 to 42 for stress, but happiness tends to go down from 14 to 10 to 10 to 8. And so as stress increases, happiness tends to decrease. So we have a negative direction. If we calculate the Pearson correlation coefficient on this data, which you will learn to do on the next video, we'll get an R of negative 0.93. So this is still a strong correlation. It's a little bit weaker than the last one because the other one was 0.98 and this is 0.93. And it's in the opposite direction. We have a negative direction. So remember, when we're looking at the Pearson correlation coefficient, the strength, it doesn't depend on the positive or the negative. It depends on the number part. This is a pretty strong correlation. It's a little bit weaker than the 0.98, but it's still pretty strong. And this is a negative direction. So here we have some scatter plots. This is a positive one. And as stress increases, so does depression. So if you see a scatter plot like this, and the dots tend to be in the left bottom corner and the top right corner, this would be a positive direction. And there's a pretty strong correlation there. That's positive. And then we have a negative one here. So as stress increases, happiness tends to decrease. And you can see this is a negative correlation. And if we have dots that tend to be in the top left corner and the bottom right corner, that would be a negative correlation. This one's a no correlation, so if the dots are random, this would be an example of no correlation, and the R would be around 0. The Pearson correlation coefficient would be around 0. So here we're going to talk about a perfect positive correlation. So here we have our scatter plot, and if you have an R of 1, that means that we can predict with 100% accuracy what y will be with our x variable. So all the dots are on the line, and that's what happens when you have a perfect correlation. So perfect correlation, I'm talking about the strength. So it could be positive or negative. In this case, it's positive. So we know that if stress is 1, that our depression level will be 3. If our stress is 2, our depression level will be 6. And if we keep this perfect correlation, if we collect more data and it's still a perfect correlation, we would know that if our stress level is 4, that our depression level would be 12 here. So that would be perfect because it's on the line as well. So a perfect correlation has dots that follow a straight line. If you have a perfect negative correlation here, we would have -1 for R, and it would still be on the line. And we can predict with 100% accuracy what our happiness would be depending on the stress level is. Now, real perfect correlations never really happen, but you kind of get the idea. We can predict with 100% accuracy what our outcome variable will be with our predictor variable. Here's some examples of different strengths. So the first two in the first column are both 0.7 strengths. They're pretty strong. The dots are pretty close to the line. So the closer the dots are to the line, the stronger the strength, because the more accurate we can be when we are predicting the outcome. The top one is positive and the bottom one is negative, but they have the same strong strength. This 0.3 is, weak or moderate, depending on what you're studying. We'll go in more detail about that later, but they're both the same strength again. The top is positive and the bottom is negative. And the last two both have a strength of 0, so there's not really a correlation here. The dots are random, so we can't predict with any accuracy what the outcome variable will be with our x variable or predictor variable. We have no idea what it will be. It's just random. So we go from pretty strong that we can accurately predict our y to we can't really predict it at all because it's just random. And just remember that strength tells us nothing about the rate of change, which is the slope. So both of these have perfect strengths of 1, and then they're both positive as well, but you can see that as x increases, y increases more for the first one than for the second one. And so R is not about the rate of change or the slope of the line. It is only about how close those dots are to the line. And remember, it's only for linear relationships. So that means it's only for straight line relationships. So this one is a curved line. So if we really wanted to plot a line for it, it would look something like this. It'd be curved. But the Pearson correlation can account for this. You can do other things to account for it, but we're not going to learn that in this class. So if you plot the scatter plot and it looks kind of curved, the dots are making this kind of the curved pattern, then you don't do the Pearson correlation. This is actually a perfect relationship. You can predict pretty well what your performance level will be depending on your anxiety level according to this made up data, but the Pearson correlation would actually be, it would be positive, but it'd be pretty weak. But you can see, if you have little anxiety, you might not study a lot and you're not doing so well. And then if you have a medium amount of anxiety, you're going to study really hard and do well on the test. But if you have too much anxiety, then maybe you can't really concentrate at all or study. So your performance level will go down. And that's a valid, relationship. But you're not going to see it if you're analyzing it with a Pearson correlation. So just be careful of that. Be careful of these other relationships out there that might not be linear or straight. Just keep that in mind, okay? Do not use Pearson correlation on curved relationships.